What is good, spaced out viewers? We've got a coronal mass ejection warning and a solar flare warning in effect here at the Smash News Network, least busted name in news. Let's take a look at a ton of data, tons of things to talk about today. Here's the closest star in two wavelengths from the SDO, ionized helium and ionized iron. We've got close-ups for you of that active southeasterly region there. Again, coronal mass ejection warning and solar flare warning in effect, especially because of sunspot 2887, which is this bright region right here. It's beta gamma class. Let's take a look at the magnetic fields real quick. This is the browse data feature, by the way, on the SDO website. And there you can see most of the magnetic organization happening in the southern hemisphere here. Spectacular imagery there from the SDO. Here's a close-up of that same area. This is 94 angstroms ionized iron. It takes 10 images per minute instead of only 2, like 131 angstroms. Only 94 and 131 take 10 images per minute on the SDO. They're specifically formulated to view things like solar flares. Here's 1700 angstroms. This is just part of the extreme UV spectrum. The radioflux has come up to 87. We've got more spectacular close-up images of that southeasterly limb of the sun toward the end. Radioflux is at 87. So for you new viewers out there, the upper chromosphere and lower corona, this little area right here produces radio frequency. And by measuring the radio signal flux density in solar flux units, which coincide with 10,000 joules of radio flux density, we get the 10.7 centimeter radio flux. There's the 1-year chart of it. The black line is the radio flux. The red line is the sunspot number. You can expect to see this rise a little bit more as a new sunspot has also risen northeast at a higher latitude, actually. Rather a lower latitude, closer to the equator than sunspot 2887. We'll show you that toward the end of the video as well in high res. So here's the Space Weather Enthusiast dashboard. We don't see any solar storms forecasted at the moment. Let's take a look at global seismicity. Largest quake of the past 24 hours was this 6.2 in the northern regions there of Taiwan. Looks like a pretty unpopulated hilly area there. And that one came in pretty recently here, just earlier this morning. So let's just scroll up the list here. No other major quakes here. That's the only 6+ magnitude quake. In fact, it looks like there's hardly anything even over a 5 magnitude. Here's an interesting one in California, though. It's a 3.3 magnitude near Loyalton, California, at a depth of negative 1.9 kilometers, 1,900 meters above sea level is the estimated depth of that 3.3. Philippines saw a 5.0. So yeah, pretty much a lull in seismicity here over the past 24 hours, except for that 6.2 and some minor quakes in places like Utah, where there was a 3.3 just recently in the past couple of hours. How about volcanoes? I'm wondering what's erupting, so I'm going to share it. La Palma, still exploding, causing evacuations and so on. On La Palma, it's producing a 10,000-foot plume of volcanic ash. Subanosejima, 9,000-foot plume of volcanic ash there, flight level 090. Yasur exploding with a 4,000-foot ash plume over Tanna Island, Vanuatu. And it looks like we've got some time-lapse photography to show you here. There's some eruptive activity from Yasur. Please don't pole vault the caldera if you're going to visit. In fact, stay outside the exclusion zone, whatever it might be. Fuego in Guatemala, producing a 1,500-foot ash plume. 1,500-foot ash plume as Fuego explodes. In Guatemala, Nevado del Ruiz has dispersed its volcanic ash, fertilizing Colombia. Revenador exploding, 16,000-foot ash plume over Ecuador from Revenador. Sabancaya exploding, 24,000-foot ash plume over Peru. And in central Chile, Nevados de Chilean has produced a sporadic puff. A reminder to not pole vault the caldera, but do visit the links below the video. Yes, visit the links. Perhaps pick up some merch. They make fantastic gifts. We've put them in order of best selling, yes. So yeah, pick up some merch for your friends and foes. It's a great time to be shopping for interesting merchandise here. These things come in all kinds of different products. And if you'd like a specific product, let us know. If it's not listed, maybe we'll list it for you. I would say to each of our viewers, Universum Liberate. Also, welcome to the Neo-Renaissance. Visit our homepage, smashomash.com, linked below the video as well. You can click on that link right there to find the Redbubble shop, which is of spectacular print quality. Spectacular print quality at the Redbubble shop. So check it out. Welcome to the Neo-Renaissance. Universum Liberate. My vaccination status is none of your business. Here's the GOES magnetometer over the past 3 days. And we saw a divergence happening here in the GOES 16 and GOES 17 as a North Pole current sheet hurtles our way. So the tug of war has been won by the Southern Hemisphere. Yeah, yesterday's thumbnail and yesterday's title for our space weather video included information about a magnetic tug of war going on. And here it is. The South Pole has won, folks, which is causing a North Pole current sheet to be in the Earth's near future. So you can see the latest image here, a current sheet headed our way in the northern polarity, shown there in green. That's a North Pole current sheet right there. Earth about to snap into it, and probably in the process of snapping into a North Pole current sheet at the moment, mainly as a result of all those sunspots in the southern hemisphere. So here is the line of sight view of that data. It also shows you the solar magnetogram from this view. And you can see all of that magnetic organization in the southern hemisphere. Here's a line of sight coronal hole plot, and you can see North Pole coronal holes shining through out here. Right there. They are now transequatorial in nature. There's the latest image you can see stretching way down in the southern hemisphere as cycle 25, solar cycle 25, progresses. It's been taking its good old time, but that is a bit of a move there. Transequatorial coronal holes. Here's a visual of it in 193 angstroms from the SDO. And you'll see this area up here. This is all North Pole oriented. This whole area here, that's all North Pole oriented coronal hole region. And those should get a little more defined as they rotate a little more into the earthly zone. Let's continue on. Here's your detected sunspot groups data. This is from the Integrated Space Weather Analysis Center. It's right on the first page. ASSA, detected sunspot groups, and magnetogram. Sunspot 2886, 2887, and I believe this one up here is going to be called 2889. I think this one was called 2888. Don't quote me on it. I don't memorize anything I can look up, a la Einstein. So here's the solar flaring over the past 3 days. No major flares. Don't be surprised to see a major flare. That's why we have a solar flare warning in effect. No spikes in the proton flux, no coronal mass ejections headed our way, but there is some coronal hole wind likely headed our way. And here's the real-time solar wind data. Just saw a mild uptick here in the solar wind density and the speed. Current solar wind density about 11 protons per cubic centimeter. Solar wind speed around 350 kilometers per second. Also, the BTBZ just went into positive territory, decreasing the likelihood of any sort of geomagnetic unrest. Are you aware that standing waves form when the solar wind strikes the Earth's geospace? Yeah. When these protons come in and they strike Earth's magnetic moment, they've got some choices they have to make. They can either bounce off and be reintegrated into the solar wind. They can get stuck in Earth's field-aligned currents, like this, where they spiral in and cause things like the aurora borealis to happen. And some of them will get stuck in the plasmaspheres, in these magnetically neutral regions here, which are surrounded by fields of electrons and other charged particles that tend to constrain them within those magnetic field areas. Yes, it's true, folks. And there's a great article about it here on SciTech Daily. When the solar wind slams into Earth's magnetosphere, a surprising stillness ensues. Yes, standing waves are created as the magnetic field environment attempts to equalize to reach static equilibrium, I'll just say. Magnetohydrodynamic equilibrium. So you'll find stories regularly about this. Here's a little animation of it from SciTech Daily. It's from SciTech Daily's own YouTube page. I'll mute the sound here just to show you the simulation results here, similar to the geospace magnetosphere movies that we look at daily. Induced magnetism caused by particle forcing as protons strike the magnetosphere and decelerate and create radiation and emit all kinds of electromagnetic frequencies. And they're forced to change their speed massively. So perhaps go check that out. I'm not going to play the magnetosphere sounds as we don't want any copyright strikes. The article's entitled, "When the Solar Wind Slams into Earth's Magnetosphere, a Surprising Stillness Ensues." Yes, standing waves are created by that. Continuing on, the KP index quite calm here over the past 3 days. Current KP index 1, KP1. It's a measurement of global geomagnetism for you new viewers. And by the way, to you new viewers, congratulations on realizing our channel exists. Leave us a comment, let us know how you found us. And thanks for watching. Here's the geospace magnetohydrodynamic pressure over the past 4 hours as modeled by the Space Weather Modeling Framework. And we see a small uptick here in the pressure. That's that uptick we just showed you in the solar wind density and speed. Pretty minor. The BTBZ shifted at the same time. That's the total field and the orientation to a pole. Anyway, here are ground magnetic perturbations known as geospace delta B, changes to Earth's B field. We showed you the sun's. Here are the changes to the Earth's. There's a polar excursion going on, a geomagnetic excursion happening at the moment. Some people are unduly frightened of it. We show the data daily. It's not scary in the slightest. Polar excursions, not scary. They're probably going on all the time. That's 4 hours of data of geospace delta B. Here is what's going on in the solar system. If you're wondering where things are located, that's where they are. Mars feeling a little lonely at the moment. And I think Earth is going to just about to come out of a communications shutdown here between the Mars rovers. So communication should resume here soon. I think it's right around the time when Earth will be able to communicate with Mars once again. Yeah, the sun's providing a blockage. Let's advance this 1 week. That's where things will be in a week. We'll have a crescent waning. Next, the star chart. It's in-the-sky.org. Mine's facing to the south. I'm facing to the south. Which way do you usually face while watching our videos? Do you watch them on a large screen? Do you watch them on a small screen? Do you watch them on a medium-sized screen? Let us know in the comments. We're going to do a cosmology segment today. Once again, it'll be integrated into the daily space weather video. Not as a separate video, although we have over 200 cosmology segments in a playlist, youtube.com/smashamash/playlists. You'll find links below the video to all of that sort of stuff, so click our links. First, the astronomy picture of the day. It's the Ghost Head Nebula, otherwise known as NGC 2080. It's a, quote, star-forming and, quote, region in the Large Magellanic Cloud, satellite galaxy of the Milky Way. The Ghost Head Nebula, an appropriate seasonal astronomy picture of the day. You can go look at it yourself at apod.nasa.gov. We're not going to pick anything random today at all. We're going to talk about the local interstellar chimney. So if you know nothing about cosmology, you may think that the sun interacts with the galactic core because it orbits the galactic core, and that is not the way things work at all. If you head to plasmascape.com, yes, plasmascape.com, you'll be defaulted to this view. So I'm just going to give you a little bit of a indication of how to sort of go through this. First thing I want you to do is click on A. That will show you the poles. Now, the solar apex, that is the direction that the sun is moving with respect to the interstellar chimney. So there's the direction that the sun is moving with respect to the interstellar chimney. It's moving toward the solar apex. If we zoom out by pressing number 5, we'll have to rotate this, And there is the solar apex. All right, that is the direction that the sun is moving with respect to the local interstellar chimney. The local interstellar chimney is a giant tube, one end of which is oriented toward Cygnus, the other end of which is oriented toward Taurus. And if you rotate this around, you can see the shape of this interstellar chimney. If you zoom out by scroll wheel down, you can see the shape of this structure. That is the local galactic structure. That's the local interstellar structure, folks. And that tab that says solar apex, that is the direction that the sun is moving. The entire structure is moving toward the constellation Cygnus. So if we rotate the galaxy like this, that bright spot over there, that is Cygnus right over there somewhere, something like that. And so that structure is moving in that direction toward the constellation Cygnus. If you look at different zoom levels, you'll be able to see different things here. This is a slightly more zoomed in level to show you maybe some features within the interstellar local chimney. And then as you get closer and closer, you'll get a solar system scale view. Again, the entire system is moving toward the constellation Cygnus. So if you follow the galactic plane, if you rotate this around, there you go, moving toward Deneb. So that is the direction, right, like that. That's how the interstellar chimney is moving. And the solar apex is moving roughly 90 degrees to the right within the interstellar chimney, again, which is shaped like this. Hopefully that helps you with some astrography, giving you an idea of the actual structure of the local portion of the galaxy. Stars do interact with each other, but from 25,000 light years away, they don't really interact with the galactic core. There's a lot of dust in between us and the galactic core. It's super obvious because, well, it just is. Looking at it shows us all kinds of different spectral frequencies, and it's a massive radio source. And so here's an animation of it. It's another SciTech Daily article where somebody has recognized this feature, and there it is. You can see this modeling right here. You can see how it's pointed right toward Cygnus. No real surprise there. Great article on SciTech Daily about actual cosmology, a, quote, magnetic tunnel, end quote, that may surround Earth and our entire solar system. Yeah, it's the local interstellar chimney, folks. So we're delighted about this article. It's another example of people who have a clue what they're talking about when it comes to cosmology. This giant interstellar structure about 1,000 light years long, which is probably something like about half the distance from our solar system to Deneb, although the distance to Deneb is actually extremely hotly contested because it's very difficult to calculate the distance to a star which has one of its poles oriented directly at us, in it is a cosmic ray source. So one of the stars that is likely seeding the interstellar chimney is indeed Deneb, and here is more legit evidence to support my hypothesis. By the way, this is not something that I believe Eugene Bagashov disagrees with. Eugene, if you're watching, leave us a comment. Let us know what you think about Deneb being the source of the interstellar chimney. That's today's cosmology segment. We hope it enlightened, confused, and alarmed whoever needs to be enlightened, confused, and or alarmed. Just kidding, folks. It's not really scary at all. Let's blast through a bunch more data. No charging hazards at the moment. We do see some chaos in the electron flux. Here's the 1-year chart of the electron flux to put it in context. Here's the 3-day chart. So we're seeing low levels here, and we're seeing a little bit of chaos. Here's the forecast for relativistic electrons by NOAA. Expecting a little downtick here. Perhaps a coronal hole wind stream is expected on the way. I don't see any geomagnetic unrest or anything like that forecasted. Here is another diagram of Earth's Van Allen belts because we're going to show you the total electron content forecast next, and we see some chaos here. So you're going to see some electrons up in the northern hemisphere there around North America where they're not normally located, as well as over Antarctica. And this is typically what we see when we see things like coronal hole wind streams. We see low levels of electron flux and some chaos in the location of those electron density bands. This is going to show you the most likely spots on Earth for GPS errors, folks. And yeah, the total electron content forecast, giving us insight into things like Earth's magnetic field, as electrons are only about 1/1800th the mass of a proton. Next, another diagram. This is showing you where the F ionosphere layer is at about 300 kilometers of altitude, because here's your animated ionogram. I don't know why it keeps unanimating. Give it a minute. There we go. So here's your ionogram map. And we're seeing some anomalies once again here. We're going to show you the anomaly map as well. We'll let it play through, then we'll pause on the latest image. There's the latest image, 10:45 Universal Time. Here's the anomalogram. We're seeing some high-frequency anomalies over the northern Indian Ocean and some low-frequency anomalies over the area north of the equator. This is the difference in megahertz. That is the wrong map. Sorry about that. I thought it looked a little weird. This is the anomaly in megahertz from the 30-day median. So we're seeing mainly low-frequency anomalies here north of the equator. Again, this is departure in megahertz, anomaly in megahertz from the 30-day median. So some low-frequency anomalies here over places like the northern Pacific Ocean, the Middle East, India, mainly north of the equator. There's the latest image. That's 10:45 Universal Time. And here come bonus features. We're going to blast through them. It's Udaipur, India's ground-based solar observatory, looking at 6,562.8 angstroms, otherwise known as hydrogen alpha imagery. Coronal mass ejection warning, solar flare warning, both in effect. Major sunspots have risen, and there'll be another one named today. Let's press refresh on the latest intensitygram and the latest magnetogram. Yeah, check it out. Major umbral space going on here. Here's this new sunspot. It looks like it might be alpha class at the moment. The real place to look at is this one right here, sunspot 2887. It is legit. There are the fields. There are the fields of the new sunspot, and you can see what a different latitude this is happening at. We've got umbrae at all kinds of different latitudes at the moment. As solar activity upticks, here's the close-ups we promised you at the beginning of the video. 1,700 angstroms. Here's 94 angstroms. Just spectacular imagery. Here's 304 and 171 together. It just looks very sun-like to me. It looks very hot and bright. And last but not least, here's 171 angstroms. Just spectacular. Thanks again for tuning in. Congratulations on realizing our channel exists. Visit our links, support the channel financially if you wouldn't mind. If you'd like to see these videos continue to exist and be publicly visible and free for all to view. And may that solar wind be at your back.